We're going to look at the surface area of a triangular prism. Now, between surface area and volume, this is the harder of the two to figure out. And the surface area of an object is the area of every face added all together. Okay. So first we got to kind of figure out how many faces there are. And in a triangular prism, we got two triangular faces, right? So that's a nice start. We have one at the front. And every time I draw this in on a piece of paper, I always get confused on which is the front and which is the back. My eyes play tricks on me. Sometimes this looks like the front, or sometimes this one looks like the front, but either way. So we have two faces, face 1 and face 2. And then because there's 3 sides to the triangle, we're going to have 3 rectangular faces. And I'm just going to highlight their edges to see them, right? So we have, this is the one that would be considered like, looks like it's on top. And there's one kind of on the bottom. And then there's one at the back here. Okay, so we have a total of 5 faces if we number them. I'm going to try to number them. This was number, I don't know how to do this, 3, 4, 5. Does that kind of look like they're on different faces? This one hovering here is hard to see. But okay, so we have 5 faces. So again, let's look at it here. We've colored the triangular faces. There's 2 of them red. And then we have 3 rectangular faces, and we pull it into the net. It's a lot easier to see, right? We have 1, 2, 3 rectangular faces, and then the 2 triangular faces. Now, this triangular prism, the one that I'm looking at right now, it looks like all of the edges are the same length. I think I can do a different one. Yeah, this might. This is a little more up our alley. I'm not very good in 3 space here. Okay, let's change them to red and red again. And then, what do we have? It's green? Mm-hmm. Okay, so let's take a look at this net. Okay, now, from looking at this net, this is going to give us a hint. If you notice, this triangular one, it looks like these 2 might be the same. They might not. We can't tell by our, but this one's definitely longer, right? So the rectangular faces all actually have different side lengths. So we have to find different area for each of these and the areas of the triangular faces. So there's a lot of work in this one. Okay, so let's kind of figure that out. First, we can find the areas of the 2 triangles. Now, because there's 2 triangles, I really only have to find the area of one of them since they have the same lengths, and then we'll just multiply by 2. So what's the area of our triangle? Do you remember what it was?
Base times height divided by 2.
Base times height divided by 2. And what was our base measurement here?
3 inches.
That's right. And what is our height measurement?
2 inches.
Great. Base and height, 2 inches. Perfect. So we're going to figure this one out pretty quickly. We know it's 3 times 2. So we replace those 2 letters. Divided by 2, which is going to be 6 divided by 2. I like to write in fractions. Is that okay with you? Mm-hmm. Okay. And it's 3 what?
Inches squared.
Inches squared. Now, because this is surface area, everything's going to be squared because we're using the term area. So everything's 2-dimensional. And how many triangular faces are there?
2.
2. So we'll call that area of triangle 1. And then we know by default the area of triangle 2 must be what?
3 inches squared.
3 inches squared also. Perfect. So we figured out number 1 and number 2. So we can kind of check those 2 off our list. Those are triangular faces. Let's deal with the one at the back. I've numbered it number 5. Okay, so kind of do the edges in red. Okay, do the edges in red there. And think of it like maybe it's this one here. Okay, I know it's hard to see. Yeah, we'll talk about, put in orange. We're going to look at focusing on that one there. It's the one at the back. What is the height of that one? Of that shape?
2 inches.
2 inches. And what type of shape is it?
Looks like a square, kind of.
Yeah, it looks like a square. And that's kind of what this looks like for it. It doesn't look quite like a square in this example, but it could be in our other one. We'll find out. So we know, we'll say the area, and the area of a square is technically the area of a rectangle. Whoops. So call it the area of a rectangle. Is equal to, what is the area of a rectangle?
Length times width.
Yes, length times width. So write the 2 letters beside each other. We'll say the length is the height here. So we'll say it's the number 2. And what's the width of that one?
5.
Yeah, how do you know it's 5? It doesn't say it's 5 here, right? So how do we know that that measurement was 5? What information did you use?
Because those 2 sides are the same.
Ah, that's right. These 2 sides are the same. So the depth of this shape is the same, right? So because this is 5, that must be 5. And when we go to look at our shape, we'll put it back together. You can tell that this is what we talk about depth. This edge here, that's the depth, and all the way around the depth is the exact same. There's no changes to that shape. Okay, so that's good that you noticed that. Zoom out again. Okay, so that means the width is 5. Whoops. So if the width is also 5, what is the area of that one rectangle there?
10 inches squared.
10 inches squared. Good. And we'll call that rectangle number 5. Okay? So that was the area of rectangle 5. Okay? Because we had 5 faces. So we've done 1, 2, 3 of the faces. Let's do the one on the bottom. We'll call that number 4. So we already know the area of a rectangle. Area of a rectangle, we'll call it rectangle number 4, is length times width. And what's the length of this one here? What would you call it?
3 inches.
3 inches, that's right. And what is the depth?
5 inches.
5. It's always going to be 5 because they're all the same, right? What is 3 times 5 going to give us?
15.
Good, 15
inches
squared. Good. So now we've done 1, 2, 5. I know we didn't do them in order. 4. And there's a reason. Number 3. Number 3 is the really, really hard one to do. And the reason being is because do we have this measurement right now?
No.
Along that edge? We don't. We have the depth. We know the depth was 5. It was 5 every single time. No, there's nothing hard about that. But we don't have this measurement. We have to use something called Pythagorean's theorem to figure this out. Okay. So Pythagorean's theorem states, let's go down, I'll write it down here, that a squared plus b squared is equal to c squared. Well, c squared, or c, is this. This is the hypotenuse of this little right angle triangle. Okay. So a and b, it doesn't matter which we call a and which we call b. So we'll say this is a and this is b. So 2 will be a and 3 will be b. So we'll fill them in. So 2 goes in for a, so we have 2 squared plus 3 squared equals c squared. What is 2 times 2?
4.
4. What is 3 times 3?
9.
Good. And then c is squared. So in order to bring square to this side, you know what that becomes when we move it over?
Negative.
Okay, we'll talk about it. Let's simplify first. What's 4 plus 9?
13.
Good. So 13 equals c squared. Now, I know this is a difficult thing. They don't talk about this much. C squared. To bring this over, the opposite is called the square root. You guys talked about a square root?
Mm-hmm.
Okay, so and square root of 13 is not a nice number. So we're going to bring up our calculator and we're going to round it. Okay, we're going to look at the square root of 13 as 3.6, we're going to say, approximately. Okay, so the letter C is 3.6. And what that means for our measurements, that this arm here, we'll highlight it in maybe blue. Actually, it'd be easier if I do it on this side, since they'll be the same. It's going to be approximately 3.6 inches. So now that we have that, can we find out the area of rectangle number 3?
Yes.
Yes, okay. So let's write our formula again. I got rectangle, area of rectangle 3 is still length times width, because it's a rectangle. What is the length?
3.6.
That's right. And what is the width?
5.
Yeah, it's always the same thing. Okay, let's figure this one. This is going to be 0, 3, 15, 18. It's going to be 18. Okay, 18 inches squared. Okay, are we finished? Have we figured out the total surface area?
No.
No, that's right. It's a ton of work to this stuff. So, we'll say the surface area of the triangular prism, I put the little letters down there so we know, is equal to, well, area of triangle 1 plus area of triangle 2 plus area of rectangle 3 plus area of rectangle 4 plus area of rectangle 5. And there were 5 faces, right? Okay, so as long as I have all that information, I can add them all together. So let's go and gather it. Area of the 2 triangles was the same. It was 3. So we have 3 plus 3. Rectangle 3 was 18. Rectangle 4, let's jump up, was 15. Is that okay? Do you see where I'm getting the information?
Yeah.
Okay. And rectangle 5 was 10. Okay. So now we've got to add these all together to figure it out. Let's see. 3 and 3 is going to be 6. And I'm going to add it to 15. 6 and 15 is 21. 21 and 18 is 39. And 39 and 10 is 49. So I say it is 49 inches squared, the total surface area. And we should double check, because I'm not always the best at math. But let's check on our calculator. Come on, calculator. There we go. Our numbers are 3 plus 18 plus 15 plus 10. Yeah, 49. Okay, there we go. So that is a lot of work for the surface area of a triangular prism. That's what that shape was there.